Space is vast, really vast. It's bigger than big. It's full of mysteries, wonders that make our planet seem like a grain of sand on an infinite beach. Among these wonders are quasars, the brightest beacons in the universe. They shine brighter than entire galaxies, harboring unimaginable power within their cores. For decades, these cosmic lighthouses have puzzled astronomers, their true nature shrouded in mystery. But now, thanks to new observations from powerful telescopes like the Isaac Newton telescope, we're finally beginning to unravel the secrets behind these celestial behemoths. Picture this, a single point of light, billions of light years away, outshining hundreds of billions of stars. That's a quasar. These aren't just distant stars, they are cosmic engines of immense power, driven by supermassive black holes billions of times the mass of our sun. But what fuels these cosmic powerhouses? What triggers the birth of these luminous giants? The answer, it turns out, lies in a cosmic dance as old as time itself, the collision of galaxies. Imagine the universe as a vast cosmic ocean, and galaxies are ships sailing through the darkness. Sometimes these ships collide, setting off a chain reaction that gives birth to the universe's most luminous objects. Let's delve into the heart of a quasar. At its core lies a supermassive black hole, an object so dense that not even light can escape its gravitational pull. Don't picture a hole in space though. Think of it more like a cosmic vacuum cleaner, relentlessly sucking in everything that ventures too close. As gas and dust spiral toward the black hole, they form an accretion disk, a swirling whirlpool of matter heated to millions of degrees by friction and gravitational forces. This superheated disk emits an intense, blinding light across the electromagnetic spectrum, from radio waves to X-rays. This, my friends, is the radiant heart of a quasar. But what kicks off this process? Why do some black holes blaze with quasar brilliance while others remain dormant? The answer, as we're discovering, lies in the intricate interplay of gravity and galactic evolution. Galaxies, including our own Milky Way, are not static islands in space. They are in constant motion, drawn together by their mutual gravitational attraction. Sometimes this attraction leads to close encounters, galactic dances that can distort their shapes, trigger bursts of star formation, and, crucially, fuel the central black holes. Astronomers using the Isaac Newton telescope in the Canary Islands have made a groundbreaking discovery. They observed a group of galaxies, some exhibiting the telltale signs of recent collisions, and found that these galaxies were more likely to host quasars. This finding provides compelling evidence for the link between galactic interactions and the birth of these cosmic powerhouses. Think of it this way. When galaxies collide, it's like shaking a cosmic snow globe. The stars, gas, and dust get all jumbled up. This cosmic chaos sends vast amounts of material spiraling towards the supermassive black hole lurking at the galactic center. The black hole, with its insatiable appetite, feasts on this cosmic buffet, its accretion disk glowing ever brighter, eventually igniting the quasar. The Isaac Newton telescope's observations are like finding the cosmic smoking gun, linking galactic mergers to the birth of these brilliant objects. This discovery is a game changer. It provides a crucial piece of the puzzle in our understanding of how galaxies evolve and how these processes give rise to the most energetic phenomena in the universe. Imagine the universe as a giant game of cosmic billiards, with galaxies as the brightly colored balls. They move around, sometimes brushing past each other, other times colliding head-on in spectacular displays of cosmic energy. These collisions, though seemingly destructive, are actually essential to the evolution of galaxies in the universe as we know it. When galaxies collide, it's not like car crashes on Earth. Stars don't usually smash into each other. Instead, their gravity interacts, disrupting their paths and flinging some stars out into the vast emptiness of space. This cosmic dance can take millions, even billions of years to unfold, a slow, graceful waltz on a cosmic scale. The gravitational forces at play during these collisions are immense, stirring up the gas and dust within the galaxies and funneling it towards the central black hole, triggering the birth of a quasar. Imagine two whirlpools merging, their combined energy creating a swirling vortex of unimaginable power. When galaxies collide, they create not just chaos, but a symphony of starbirth. Galactic collisions, while triggering the birth of quasars, also set the stage for a spectacular surge in star formation. The vast clouds of gas and dust, compressed and agitated by the gravitational forces of the colliding galaxies, become fertile grounds for new stars to ignite. Imagine, if you will, a cosmic fireworks show, with new stars bursting into existence, painting the galactic canvas with brilliant hues of blue and white. These newborn stars, some much larger and hotter than our sun, burn bright but live fast, exhausting their nuclear fuel in a few million years, a blink of an eye in cosmic terms. This frenzy of starbirth, fueled by galactic collisions, plays a vital role in enriching galaxies with heavy elements, the building blocks of planets and ultimately, life itself. We are, after all, stardust, forged in the hearts of dying stars, our very existence intertwined with these cosmic collisions. Quasars, the afterglow of cosmic collisions. Quasars, though incredibly luminous, are not eternal. They shine brightly for millions of years, a fleeting moment in the grand scheme of the universe. As the black hole consumes the surrounding gas and dust, the quasar eventually fades, leaving behind a dormant, supermassive black hole at the center of a newly merged galaxy. Think of a quasar as the afterglow of a cosmic collision, a beacon signaling the birth of a new galactic giant. These remnants of past collisions, these dormant black holes, are scattered throughout the universe, silent witnesses to the ongoing saga of galactic evolution. Studying these relics, astronomers can piece together the history of our universe, understanding the processes that drive galaxy formation and the role of quasars in shaping the cosmos as we know it. The Milky Way's fate, a rendezvous with Andromeda. Our galaxy, the Milky Way, is not immune to these cosmic dances. In fact, we're on a collision course with our nearest galactic neighbor, the Andromeda Galaxy. Don't panic just yet. This encounter won't happen for another 4 billion years or so. Plenty of time to finish that book you've been meaning to read. When these galactic titans finally do meet, it will be a slow, drawn-out affair. The two galaxies will distort, stretch, and eventually merge, their supermassive black holes spiraling towards each other, potentially igniting a new quasar, a beacon visible across the cosmos. This collision, though billions of years in the future, is a stark reminder of the dynamic nature of our universe. Change is the only constant, and even galaxies, once thought to be eternal and unchanging, are subject to the forces of gravity and the passage of time. Peering into the cosmic crystal ball. The study of quasars and galactic collisions is like peering into a cosmic crystal ball, allowing us to glimpse the past, present, and future of our universe. By understanding these processes, we gain a deeper appreciation for the intricate workings of the cosmos and our place within it. These discoveries underscore the importance of continued investment in scientific research and exploration. We've only just begun to scratch the surface of understanding these celestial giants and the secrets they hold. Each new observation, each new discovery, brings us one step closer to unraveling the mysteries of the universe and our place within its grand tapestry. Our place in the cosmic tapestry. The study of quasars born from the collisions of galaxies reminds us of the interconnectedness of the cosmos. We are not isolated observers but active participants in a grand cosmic ballet, a dance of creation and destruction that has been playing out for billions of years. As we continue to explore the universe, we gain a deeper understanding not only of the cosmos but also of ourselves. We are, after all, stardust forged in the hearts of dying stars, our very existence intertwined with the grand cosmic events we observe. So the next time you look up at the night sky, remember those distant quasars, beacons shining across billions of light years. They are not just distant objects, but reminders of the dynamic and ever-evolving nature of our universe, a universe we are fortunate to call home.